Myself, Dr. Meenakshi from Applied Science Department, and I'm taking the lecture for the topic Matrices, which is Unit 1 for BAS 103, Engineering Mathematics 1. Okay. So in Matrices, I'm taking the important application of matrices, which is solution of linear system of equations. And in linear system of equations, we study about two types of equations. One is the non-homogeneous equation, and second one is the homogeneous system of linear equations. Okay. So first of all, we discuss what is the difference between non-homogeneous equations and homogeneous equations. So if we talk about, they are the system of linear system of equations. So I have taken here n number of system of equations in n unknowns x1, x2, xn. So they are of the form a11 x1 plus a12 x2 plus a1n xn is equal to b1, a21 x1 plus a22 x2 plus a2n xn equal to b2, and so on. am1 x1 plus am2 x2 plus amn xn equal to bm. So we know that any this type of linear system of equation we always represent in the form of a matrix. So I can represent this in the form of the matrix Ax equal to B, where this A is called coefficient matrix, this X is called the matrix of unknowns. This is a column matrix containing these unknowns x1, x2, xn. And this B is the matrix of constant values, which are the right hand side elements b1, b2, bm. This is also a column matrix. So any of these type of linear equation I can represent in the form of matrix Ax equal to B. Okay. So now what is the meaning that when we say that the system is homogeneous and or the system is non-homogeneous? That depend upon the nature of this constant matrix B. I have two cases for this B. Either this B is a null matrix, means you take all the value will become 0. What the meaning that B is null matrix? That all the right hand side elements of these equations is equal to 0. So in this case, this type of matrix, in this type of equations is called homogeneous system of equations. And second condition, if in B, I am getting at least one element which is non-zero, then that type of element will become something like, suppose I take 1, 0, 0. So if I am getting at least one element which is non-zero over here, so these type of system of equations will become nothing but the non-homogeneous system of equations. Yeah. So in these type of linear equations, we deal with two types of equation. One is the homogeneous system of equation, one is non-homogeneous system of equation, and that depend upon the right hand side value B. Okay. So now how we solve these type of equations? So we look at the procedure. So we starting with the linear system. I have already discussed that Ax equal to B. If B is any non-zero quantity, then that equations will become the non-homogeneous equations. And if the right hand side B is 0, then the equations will become the homogeneous system of equation. So in this chart, we are discussing how we solve the non-homogeneous system of equations. So what we do, we first form a matrix C. This matrix C is known as augmented matrix. Now we form this augmented matrix. This is the combination of the coefficient matrix A along with the matrix of constants B. In a single matrix, we arrange all the elements of the coefficient matrix along with the constant matrix B. So we form the augmented matrix over here. First we form. What we do then? After that, we find out the rank of this augmented matrix by Echelon form method. All of you know that we can find out the rank by converting our given matrix to Echelon form. So by using the Echelon form method, we find out the rank of this matrix C. So now when we find out the rank of this C, so we have two cases arise. The first case, if the rank of C equal to the rank of the coefficient matrix A, means the rank of the augmented matrix is same as the rank of the coefficient matrix, then we say that equations are consistent. Consistent means the solution exists. So the condition for the solution to exist is that the rank of the coefficient matrix must be same as the rank of the augmented matrix. Okay. For the second case over here, the rank of augmented matrix is not equal to the rank of coefficient matrix, then we say that equations are inconsistent. Inconsistent means solution does not exist. So in this case, the solution does not exist. Yeah. So Again, if the solution does not exist, then we no need to do any further exercise. But if the solution exists, then we think what type of solution will exist over here. So that depends upon the number of unknowns we have. Means if the rank of the coefficient matrix is same as the rank of augmented matrix is equal to n. N is nothing but the number of unknowns given over here. In this case, we get the solution which is called the unique solution, or this is also known as trivial solution or trivial solution, I think you can say in this case. Second condition, if rank of the coefficient matrix is same as augmented matrix, which is the condition for solution, but this is less than the number of unknowns. In this case, we have infinitely many case, infinitely many solutions, or this is also called the non-trivial solution. Yeah. So this is the chart how we are going to solve. Here we have discussed the condition only for this non-homogeneous system of equations. Now we discuss about the homogeneous equations. Now in homogeneous, since this matrix B is 0, so when we try to make this augmented matrix, what happens if this matrix B is 0? So the augmented matrix here is nothing but the same as the coefficient matrix A. Yeah. So when we talk about this homogeneous equations, in the next slide. So for the homogeneous system of equation, we have only one matrix, which is the coefficient matrix A. We find out again the rank of the coefficient matrix A by Echelon-Form method. After that, we compare the rank of the matrix A with the number of unknowns. The condition is same as above. Means if the rank is same as the number of unknowns, we have calling it the trivial solution, or I can say the unique solution. And please remember that in case of homogeneous, if you are getting the unique solution means that all the unknowns will take the value 0. This is the unique solution in case of homogeneous equations. And the second case, when the rank of A is not equal to n, means this is not equal to, this is less than n. Always it should not be greater than n. Rank of A is less than n. Or I can say the determinant of A equal to 0. Then we have the non-trivial solution, or I can say the singular solution or the linearly dependent solution. Yeah. So this is the condition when we are dealing with the homogeneous system of equations. Yeah. So now we just coming to the examples directly. The first one, investigate for what values of lambda and mu do the given system of equations x plus y plus z equal to 6, x plus 2y plus 3z equal to 10, and x plus 2y plus lambda z equal to mu have no solution, unique solution, and infinitely many solutions. So what we need to do, we have to find out the values of, we have to check the values of this lambda and mu on those. So if you look at these equations, it's clearly seen over here that they are nothing but the non-homogeneous system of equations. Means the right hand side part, you are getting some non-zero elements, is the non-homogeneous system of equations. So what we start with, we first start making the augmented matrix, which is written like this: A separated by some dotted lines and then B. This is the augmented matrix. So write down the matrix for these given equations. It's written like 1, 1, 1, separated by, this is the right hand side element, which is 6. This is 1, 2, 3. This is 10. And 1, 2, lambda, and this is mu. So this is nothing but the augmented matrix AB. Now what we need to do, we need to find out its rank by converting it to echelon form. So to convert it to echelon form, we know that we have to apply the row transformations only. So I start applying the row transformation. I first apply the transformation R2 minus R1 and R3 minus R1 to make these two entries equal to 0. Okay. So apply the transformation. The first row remains same, 1, 1, 1, 6. R2 minus R1 gives me 1 minus 1, 0. 2 minus 1 is 1. 3 minus 1 is 2. And 10 minus 6 is 4. And R3 minus R1, 1 minus 1, 0. 2 minus 1 is 1. Lambda minus 1. And here we get mu minus 6. This is the element. Yeah. Now I need to make this element also equal to 0 to convert it to Echelon form. So I apply the next transformation. What we apply? I apply the transformation R3 minus R2. Apply this transformation. The first row remains same, 1, 1, 1, 6. Second row remains same, 0, 1, 2, 4. And the third row, R3 minus R2 gives me 0. 1 minus 1, 0. Lambda minus 1 minus 2 is lambda minus 3. And mu minus 6 minus 4 is mu minus 10. And after that, since the next value depend upon the unknown lambda and mu, so we're not able to solve it further. So we left it over here. Now we want to find out the values lambda and mu so that we have the no solution, unique solution, and infinitely many solutions. Okay. So we write this matrix in the next slide. It's 1, 1, 1, 6, 0, 1, 2, 4, 0, 0, lambda minus 3, mu minus 10. Okay. Look at, we have the matrix which we have reduced. It's 1, 1, 1, 6. We look at 0, 1, 2, 4, 0, 1, 2, 4, and 0, 0, it's lambda minus 3, and this is mu minus 10. I hope I have written correctly. This lambda minus 3 and mu minus 10. Okay. So what we need to do now, we have to investigate the value lambda and mu such that these equations have. So first I am taking the condition for no solution. So first I think about the condition of no solution. What's the meaning no solution? No solution means that the rank of the coefficient matrix is not same as the rank of the augmented matrix. Let I denote the augmented matrix by the matrix C, it's the reduced augmented matrix. The rank of A is not equal to the rank of the augmented matrix C. What the meaning that both the ranks are not same means, let us suppose that its rank will become equal to 2 and this augmented matrix rank will remain same as 3. So what the meaning that its rank, if I hide this last column, so to make the rank of this coefficient matrix equal to 2, what I have the condition that lambda minus 3 must be equal to 0, means lambda must be equal to 3. And what the condition that this augmented matrix remain and the rank 3. So for this to be rank 3, this element must be non-zero, means mu minus 10 should not equal to 0, means the case mu should not equal to 10. So this is the first condition for lambda and mu values for getting the no solution case. Okay. Coming to the second condition means we are taking the condition for now unique solution. Now what is the condition for unique? We know that it should be rank of the coefficient matrix is same as the rank of augmented matrix. This is the condition for solution to exist. And this is same as equal to the number of unknowns. If we think about the unknowns here, so we have 3 unknowns, x, y, and z. So both the rank must be equal to 3. Now look at what is the meaning that rank of this coefficient matrix is 3. If I write down this matrix again, this is already 1, 1, 1, it's 0, 1, 2, 0, 0. What should be this element so that its rank is 3? I know that in Echelon form, the rank is same as the number of non-zero rows. So means this element must be non-zero. So what is the condition for this element? Means I get that lambda minus 3 should not equal to 0. Means lambda should not equal to 3. This is the condition for lambda. Means this is getting something like I am getting the value which is non-zero over here. I am getting some value. I fix this value as non-zero. Now coming to the value of mu, I write it further. This is 6, 4. Now what about this value? What should be the value of this mu? Now think about that this value is already non-zero here. So in this third row we are getting one element which is non-zero. So what about this? Maybe this is 0, maybe this is non-zero, that doesn't matter. The rank of this augmented matrix will remain as 3 again. So this value does not depend upon this 10, means here what the condition? Mu can take any value. Maybe this value is 10, maybe not equal to 10. Here mu can take any value. Means this is also written here that mu belongs to the set of real numbers. I can write like this also. Mu belongs to the set of real numbers for the unique solution. Now coming to the third case, which is infinitely many solutions. Infinitely many. I know that for infinitely many, both the rank must be same because it's the condition for solution to exist. But this must be less than the number of unknowns, which are 3 over here. Meaning that rank of both these matrices must be less than 3. Means if the last row become total, the 0 row, in that case rank of coefficient matrix is also 2, rank of augmented matrix is also 2. What the meaning that the last row is 0 row means this lambda minus 3 is also equal to 0 and this mu minus 10 is also equal to 0 means lambda equal to 3 and mu equal to 10. This is the condition for no solution and this we have derived the condition for unique solution. Yeah. So these are the 3 cases for solution to exist for the no solution case, unique solution case and infinitely many solutions case. And it's a very important example in this topic, solution of non-homogeneous system of equation. Yeah. So now I'm coming to the second example. Find the value of k for which these system of equations are 3k minus 8x plus 3y plus 3z equal to 0, 3x plus 3k minus 8y plus 3z equal to 0 and 3x plus 3y plus 3k minus 8z equal to 0 have a non-trivial solution. What the meaning non-trivial? Non-trivial means they have infinitely many solutions. This is the meaning non-trivial. So you need to find out the value of this unknown k such that these equations are provided with the infinitely many solutions. Infinitely many means if you think about infinitely many, and once again, since the right hand side part of all these 3 equations is 0, so these equations are nothing but the homogeneous system of equations. These are homogeneous system of equations. So you know that in homogeneous, if we need to talk about the infinitely many case, what the meaning for infinitely many? Infinitely many means that rank of the coefficient matrix must be less than 3, less than the number of unknowns, which are 3 here. Okay. And what the meaning that the rank is less than 3? If you think about the minor method, you say that the rank is less than 3 means the 3 by 3 order minor must be equal to 0. So for this we have taken the determinant of 3 by 3 order matrix A must be equal to 0. Yeah. So we start with this in these type of questions where you are provided with some unknown values. According to that, if you are provided that you are satisfying the trivial or the non-trivial solution, then in most of the cases you start with this minor method, taking the value determinant of A equal to 0. Yeah. So now I form this A determinant. From this, if I write down in the form of determinant, I can write 3k minus 8. This is 3, this is 3, 3k minus 8, this is 3, and this is 3, 3 and 3k minus 8 value. I'm writing this in the form of determinant. Now I now need to expand this determinant. I put this is equal to 0 according to my given condition. So I need to solve it. So first we need to evaluate it. I look at that if I add these 3 columns, means if I apply the transformation C1 plus C2 plus C3, because all the elements are same in each the column. The determinant is this. So adding the values, I can write this is 3k minus 8 minus 3 minus 3. So I add the values. This is nothing but 3k minus 8 plus 3 plus 3. This remains same as 3, 3. This is 3 plus 3k minus 8 plus 3 and this will remain as 3k minus 8 and 3. And this is the value 3 plus 3k minus 8 and this is 3 and 3k minus 8. I'm getting some this type of determinant equal to 0. Now when I solve it, look at what we get. 3 plus 3 is 6 minus 8 plus 6 minus 2. So I get here 3k minus 2, here also it's 3k minus 2 and here also it's 3k minus 2. Other elements remain same. So in the first column, what we are getting 3k minus 2 everywhere and this is 3, 3, 3k minus 8 and so on. So look at, I'm writing this in the next step. In the first row, we are getting each and every element of the row are 3k minus 2. So I write in the next step, value. Look at. So I write down that this is nothing but 3k minus 2, 3k minus 2, 3k minus 2, the first row element. What about the next row? It's 3k minus 8, 3, 3k minus 8, 3, and this is also 3, 3 and 3k minus 8, and I put this equal to 0. So what you do next? You know that this is a determinant. You can take the common element of the row 1, of the column 1, common outside. So I'm taking this 3k minus 2 common out here, and inside I'm getting 1, 3, 3. This is 1, 3k minus 8, 3, and this is 1, 3, 3k minus 8. Now it's very easy to simplify. I can solve it further by applying the row transformations. So I'm applying the row transformation R2 minus R1 and R3 minus R1. Okay. So this is 3k minus 2. Yeah. The first row remains same, 1, 3, 3. What about the second row? It's 1 minus 1, 0. 3k minus 8 minus 3. What will get? 3k minus 11. 3 minus 3, 0. 1 minus 1, 0. 3 minus 3 is 0. And 3k minus 8 minus 3 is again 3k minus 11. Put it equal to 0. And now this is very simple to expand. We expanded by the first column. So when I expanded by the first column, these two elements are 0 and 1 into this gives me 3k minus 2 into 3k minus 11 whole square equal to 0. Solving this, what we get? I get the value k equal to 2 by 3. And from here I get two values of k which are 11 by 3 and 11 by 3. So we are getting, look at, there's a solution over here. We are getting k equal to 2 by 3, 11 by 3, 11 by 3. So these are the values of k for which the system of equation will take, we have non-trivial solution, for which we have non-trivial solutions. Yeah. So these are the questions in which you are provided with some unknown k. You need to find out this unknown under some condition that they are the non-trivial. These equations have the non-trivial solution. So you have taken the case that for non-trivial, you have taken the case the determinant of A must be equal to 0. Just solve this determinant. We apply the row or column transformations. Put it equal to 0. So we are getting 3 roots of k. So this topic is an important application of matrices, and we can solve it by using any type of linear equations, whether they are homogeneous equations or the non-homogeneous equations, you able to solve by using the matrices. Thank you.